We want to now look at some probability rules. So we will start with the basic rule of probability, then we'll look at the complement rule. So we want to look at some probability rules. So we'll start with number one, basic rule of probability. Now, what is this basic rule? The idea is that if all outcomes are equally likely, then probability of event A happening is, again the keyword here is all outcomes are equally likely, then probability of event A happening is probability of A is number of outcomes favorable to A divided by total number of outcomes. This is what we call the classical approach to probability, where we find probability as number of favorable outcomes by total outcomes. So this is classical approach to probability. The keyword here is this approach only applies when all outcomes are equally likely. So this is a warning here to keep in mind, a warning. We can only apply this. We can only apply this classical approach to probability problems in which all outcomes are equally likely. So when you're finding probability as number of favorable outcomes by number of total possible outcomes, that only can be applied to problems in which all outcomes are equally likely. So this is key, right? It can only be applied to problems where all outcomes are equally likely. Let's look at an example of such problems. Like one could be you toss a fair six-sided dice. Again, the keyword here is fair. You toss a fair six-sided dice, right? Because if it's fair, then all outcomes will be equally likely. You toss a fair coin. Again, the keyword is fair. You toss a fair coin. Again, the keyword is fair, right? Because that would ensure all outcomes will be likely. You randomly guess. Another example could be you randomly guess the answer to a true-false question. You're randomly guessing, right? Randomly guess to a true-false question on an exam, right? So on an exam, you're randomly guessing the answer to a true-false question. So in this case, you're equally likely to select. You are equally likely to select a correct or incorrect answer. Right, so in this case, both outcomes, whether you select the correct answer and whether you select an incorrect answer, equally likely because you're just randomly guessing. So, right, that is why in this case we can say probability of the correct answer is 1/2, probability of incorrect answer is 1/2 because you're randomly guessing. So each outcome is equally likely to being correct and being incorrect. Right, so being correct is equally likely, being incorrect is equally likely. So in this case, you can find probabilities as number of favorable by number of total because outcomes are equally likely as you're just randomly guessing. So just keep in mind the classical approach to probability, which says you can find probability as number of favorable outcomes. The total possible outcomes can only apply when all outcomes are equally likely. So that's key over here. So the second rule we're going to look at is going to be the complement rule. The complement rule says that probability of A is 1 minus probability not A. This is what the complement rule says. Now, often when you see at least or at most in a problem, at least or at most, it may require, it may be easier to use actually the complement rule. It may be easier to use complement rule to first find probability of not A and then obtain probability of A. Right, so complement rule, often when you see in a question the word at least or at most, it may be easier that you first find probability of not A and then from there obtain probability of A.